this going. So just so you guys know, tomorrow, what are we going to do in class tomorrow? Literally nothing. Nothing. You're not going to be here, so nothing at all. You're not missing anything. I mean, if you want to work on filling in the evens that we skip over today, that's fine if you want to, but you don't have to. I'm not going to expect it. Okay, we don't have class at all. None of my Algebra 2 classes do. Okay, so we're going to introduce you to a new number. Okay, and we talked about this before. I mean, I taught you a new number this year, not too long ago, a couple months ago. We'll talk about that in a second. But I mean, you learned way back when you were a kid. You learned the numbers 1, 2, 3, and 4, and so forth. And then, you know, when you got to be a little bit older, I mean, if you asked a little kid, you know, what comes after 1, they say 2. What comes after 2, they say 3. Well, if you ask a little kid, well, what comes between 1 and 2, they're going to say, well, nothing comes between 1 and 2. 2 comes right after 1. Well, then they learned about fractions and decimals, okay, and those exist. They just didn't know about them at the time, okay? And then I introduced you to another number, the number I, okay, the number I. And remember, be careful. Some students say, well, I is -1. I is not -1. I is the square root of -1. We learned that number, the imaginary number, I, okay? There's another number that it looks kind of weird that I know you all know. You might think, what's he talking about here, okay? This number right here. What number is that?
3.1.
I'm glad you said that. That's not it. It's not 3.14. That's not what you say. That's not what that is. It's what? That's the number pi. Now I'm really glad that IOB said that, okay? Because that is not 3.14. Pi is not 3.14. It's not 3.14. If you're going, wait a minute, teachers told us it was. They did. Maybe you misheard them or they misspoke a little bit. Pi is not 3.14. Like, for example, I'm going to take a stab here. IOB, true or false? You're 16 years old?
False.
Okay, you're 17 years old.
True.
Okay, I disagree. I bet he's not 17 years old. Okay? Seriously. And I'm not saying he's, well, he's, let me throw another one. You're exactly 17 years old? You're exactly 17 years old? No, you're not. What if it's your birthday today? Then are you exactly 17? Why not?
Because it's the second after you were born.
Well, yeah, I mean, well, even if it was your birthday today, happy birthday. Okay, I'm not getting anything. You'd be 17 years and a few hours. And then, can I get even more specific than that?
Yeah.
Maybe a few minutes or a few seconds. Can I get it more specific than seconds? Tenths of seconds, hundreds of seconds. How long are you exactly 17 years old? Not even a second. I mean, not even a blink of an eye. Because even a trillionth of a second later, you're older than 17, okay? But it's a good approximation. Now, when you say that's 3.14, it's about 3. 3.14 is a pretty good approximation, okay? But it's not exactly 3.4. It's actually 3.14159, and it goes on forever. That's as far as I've memorized it. I'll take your word for it. Okay, you could. Okay, you could have been saying a bunch of gibberish, and I'd say whatever. And I'm not being flippant here, but I really don't care. I mean, again, thank you for saying that, and I'm good that you memorized it. But do you need to memorize it that far? Not necessarily. Do you need something?
Oh, I'll wait till you're done talking.
I'm going to be up here for probably a half hour.
Oh. Would I be able to take my test today?
In class, probably, yeah.
Oh.
Yep. Yeah, I'll probably have you do that, and then I'll just have you watch a video.
Yeah.
That I
so
think.
you get 6.12.
Yep. Yep.
3.14152. There's a 2 in between 9 if I remember correctly.
You missed it. It's incorrect. That's correct. I know that part's right. That's as far as I've got. After that, I have no idea. Okay, so these are all numbers here, okay? The new number that you're going to learn is this number. The number E, and it's lowercase e. If you're going to write it down, don't put down capital E. It's not a capital E, okay? It's lowercase e. Now, and again, what is E? It's about, these little wavy lines, it's like an equal sign, but that means approximately equal to. It's approximately equal to 2.71. Okay, you might want to jot that down. E is approximately 2.71. Now, what I was saying about 10 minutes ago was this. I really think the assignment itself is going to be pretty easy for you today. But you'd be like, what's the point? I don't get this, okay? The number E has lots and lots of applications when you get into higher level math, especially calculus, okay? So for right now, we're going to teach you how to do it. The why behind it, I hate doing this as a teacher, but the why behind it, I wouldn't really worry about right now, okay? Eventually, we'll get some of the reasoning behind why we're learning this, okay? Question?
Have we done anything with that pi yet?
No.
Oh, okay,
Well, you've seen that. I mean, you've seen that like in middle school, like in geometry and so forth. You remember pi, right?
No.
Like circles and stuff. Pi r squared in geometry.
I remember doing that, but I don't remember
The symbol?
symbol, yeah.
Oh man, I would have thought that you'll use it a lot when you get into trigonometry next year. Okay. So yeah, do you need to know this right now? No, you don't. But I mean, it is a number that you at least should be aware of. Okay. Okay. Okay, so where the heck do they get this? They just say, well, we're just going to say it's about 2.71. No. Here's what it is. Now, I'm not going to make you memorize this. You do not need to memorize this. You should memorize this, that E is about 2.71. Where it comes from is this, okay? It's 1 plus 1 over x to the x power. That's what E is. 1 plus 1 over x to the x power. I'm not going to make you memorize that. I just think it's important that you understand where it comes from, okay? And the analogy I'm going to use is what I was doing with Iobi when I talked about his age. Now, when somebody asks you your age, you typically say how many years old you are, okay? Now, do people always measure their age in years? Not really. For example, what'd you say? A baby. Yeah, if it's like 3 days old, you don't say, well, it's 0.001 years old. You say they're 3 days old, okay? I mean, you could, okay? But no, usually you measure babies like in days and then weeks, then eventually months, and then eventually you start doing it in years. I mean, it's not wrong. I mean, could we measure your age in seconds?
Yeah.
We could. It'd be a huge number, though, okay? All right, so here's what we're going to do. Now, what the heck is x? X can be whatever you want. Just like when I measure your age. I can measure your age in days, weeks, months, years, whatever, decades, whatever, okay? So, I'm going to plug in, for example, I'm going to plug in 1 for x, okay? And I plug in 1 for this x and 1 for this x. So it's 1, and just watch. Don't write this down. 1 plus 1 over 1 to the 1 power. I just plugged in 1 here, and I plugged in 1 here, okay? 1 over 1 is 1. Plus 1 is 2. So 1 plus 1 is 2 to the first, and 2 to the first is 2. Now I'm going to plug in 2 for both of these x's. Bless you. 1 plus 1 over 2 to the second. I plugged in 2 for both of these, okay? 1 plus a half is 1 1/2 or 1.5 squared. 1.5 squared is 2.25. Okay? I'm going to plug in 10 this time. This is where I'm going to need your calculators. I could do these first two in my head. After this, I can't. So I have 1 plus 1 over 10 to the 10th power. 1 over 10 is 0.1. 1 plus 1 plus 0.1 is 1.1. So 1.1 to the 10th power. Somebody got a calculator? They punch that in for me, please. 1.1 to the 10th power. And just shout it out. And give me like 3 or 4 decimal places. 2 point what?
2.51.
5 what?
9,
5, 9. One more. 3?
3, 7.
Okay, that's good enough. 0.593. Okay, let's plug in 100. 1 plus 1 over 100 to the 100. 1 over 100 is 0.01. 1 plus 0.01 is 1.01 to the 100. Okay, Hope, what's 1.01 to the 100th power?
2.704.
0.704? And what the heck, let's do one more. Let's plug in 1,000. So 1 plus 1 over 1,000 to the 1,000. 1 over 1,000 is 0.001. 1 plus 0.001 is 1.001 to the 1,000. What's 1.001 to the 1,000? What's that?
I might have typed it in.
Okay. 1.001 to the 1,000, bless you.
2.716.
716? Okay. All right, so we're done typing stuff in. What's happening to my number? As I plug in bigger numbers for x, what's happening to this number? It's getting bigger. It's getting bigger, okay? But it's getting bigger slower, okay? 2 up to 2.25.
Approximately.
What's that?
But it's close to 2.7.
It's very close to 2.71, okay? And actually it's 2.71 and there's numbers after that. I just don't have it memorized, okay? Now, I think I used this analogy with you guys. If not, I'm using it a ton. If I talk to you guys about walking across the room half the distance,
Yeah.
okay, so what I want you to understand is kind of the same analogy, okay? If every day I walk half the distance, theoretically I never get there, okay? Because I keep walking every day, but every day I keep walking less. Like if it's 40 feet, I walk 20 feet the first day. The next day I only walk 10 feet. The next day I only walk 5 feet. So I continue adding on, but I keep on adding on smaller and smaller and smaller numbers, okay? So what I'm